Hello and welcome viewers. We are in the second segment of counters. Now, have you ever wondered how does digital stopwatches count down the time? This is where asynchronous down counters come to play. We have already discussed that asynchronous counters can be divided into two categories: asynchronous up counter and asynchronous down counter. Asynchronous down counters are also used in frequency dividers. Here, we will briefly discuss about asynchronous down counter. A counter with n number of flip-flops counts downwards, starting from a maximum count of 2 to the power n minus 1 to 0, where n is the number of bits. The counting sequence of such a 3-bit counter is given as: the following type of counter can be designed using 3 cases. For case 1, here we see in the circuit, the T of all the flip-flops are connected to the plus VCC or 1. The first T flip-flop is connected to the clock line, whereas the clock of the corresponding flip-flops is the Q output of the preceding flip-flops. The outputs of the counter are taken from the complement outputs of the flip-flops, that is Q bar, whereas Q bar 0 is the LSB and Q bar 2 is the MSB. Now, as we have known from the up counter, at every negative edge of the clock pulse Q0 changes its state. Similarly, for every negative edge of the Q0 output, the Q1 changes its state, and so on. Similarly is the case for Q2. Now, we see that the complements of the corresponding outputs of the flip-flop is of the fashion Q bar 2, Q bar 1, Q bar 0 is equal to 1, 1, 1, which is equal to 7. Hence, the count decreases from 7, 6, 5, 4, 3, 2, 1, 0 and again 7, and so on with each clock pulse. For case 2, here we have slightly modified the circuit where the clock inputs of the second and third flip-flops are derived from the Q bar outputs rather than Q outputs of the preceding flip-flops. The outputs are derived from the Q outputs where Q0 is LSB and Q2 is the MSB. From the waveform, we see that the initial clock counter content is 0, 0, 0, and at first negative transition of the clock, it changes to 1, 1, 1. At the second negative transition of the clock, the counter content changes to 1, 1, 0. At third negative transition of the clock, the counter content changes to 1, 0, 1 and so on. Hence, here too, the count decreases from 7, 6, 5, 4, 3, 2, 1, 0 and 7 and so on with each clock pulse. For case 3, here we are replacing the flip-flops with positive edge triggering flip-flops. Here in the circuit diagram, we have connected the T of all flip-flops with VCC or 1. The first T flip-flop is connected to the clock line, whereas the clock of the corresponding flip-flops is the Q output of the preceding flip-flops. The outputs of the counter are also Q output of the flip-flops, where Q0 is LSB and Q2 is MSB. From the waveform, we see that at every positive edge of the clock pulse Q0 changes its state. Similarly, for every positive edge of the Q0 output, the Q1 changes its state, and for every positive edge of Q1 output, the Q2 changes its state. In today's lecture, we have learned Introduction to Asynchronous Down Counter, cases for implementing asynchronous down counter. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.